Okay, chapter 4 is about system of equations. And in this section, we will learn how to solve system of equations. Okay, the system of equations has two or more equations, and each equation has two or more variables as well. So here is an example one. Okay, there are two equations. This is the first equation. Here's another equation. So combining this equation is a system of equations, and each equation is a linear equation, so we can say this is a system of linear equation. Then, okay, in this case, we will check whether each given point, given order pair, is a solution to this equation. Okay, solution to the equation means, okay, actually when you draw each equation, in this case straight line, each equation, and the intersection, this intersection of 2 points, two lines, intersection of two lines is the solution. This is the solution. So this point has to lie on this line also, as well as on this line. So in order to check if the given point is a solution to the system of equation, we have to substitute this order pair for each equation. So let's check the first equation if this point is satisfied. Okay, the first equation is x plus y is equal to 6. Let's check if this is equal. So substitute 3 and 3 for x and y. 3 plus 3 is 6, and this is equal to 6. So the first equation is okay. It satisfies the first equation. How about the second equation? Second equation, we have to check whether it satisfies the equation. Okay, so x equals 3, so 2 times 3 minus 5 times 3. 6 minus 15, so that is negative 9. And negative 9 is not equal to 2. So this point is on the first equation, but this point is not on the second equation. So this order pair is not a solution. Okay, let's check another one. Okay, x is 4, y equals 2. So let's check each equation. So x plus y is 6. Okay, 4 plus 2 is 6. So this is true. So the first equation is okay. How about the second equation? Let's check if the order pair satisfies the equation. Okay, x equals 3, so 2 times 3 minus 5 times 3, then 6 minus 15. Y equals 2, right? Y equals 2. So 5 times 2. Then 6 minus 10 is negative 4. 4 minus 2. Okay, I substitute wrong x. Okay, I'm sorry, x is 4. X is 4. So 8 minus 10, then negative 2. So the left side of the equation is negative 2. The right side of the equation is negative 2, and they are same. So the second equation is true. So that this line is on the first equation, second equation, so that this line is the intersection of two lines. So yes, this is the solution. Okay, when we solve a system of two linear equations, then the graph is one of these three. Okay, the first type is two lines intersect at one point, and okay, so this is the solution actually, and the slope of these two linear equations is different slope, and this one has exactly one solution. The yellow is no good, so let's change it to blue. Okay, this has only exactly one solution, and the slope is different. Also, the second graph the two equations are exactly the same. Two lines are exactly the same, so they have the same slope and same y-intercept. How about the solutions? Okay, solutions are all the points on the line, all the points. So there are infinitely many solutions, infinite. Okay, this is a symbol for infinite. So there are infinitely many solutions. Okay, the third type is two lines are parallel. Two lines are parallel, but they never, since they are parallel, they never cross each other. So of course, since they are parallel, the slope are the same. They have the same slope. Of course, they are in a different location. So since they don't intersect each other, there is no solution. So there are three types of solutions. One, the first one is there's an exactly one solution. There are infinitely many solutions and no solutions. Okay, if there is a solution, then we call the system consistent. So since there is a solution here, we call this system a consistent system. And the second graph has infinitely many solutions. Also, this is consistent system. And the third one is there's no solution. So this is inconsistent. The system is inconsistent. Okay. Also, if two lines are identical, lines are identical, which means there are infinitely many solutions, then we call this system dependent. So the system of two identical lines, equations, are called dependent, and others are independent. Okay. So please make sure that there are three types of solutions when we solve a system of linear equations. Okay, in this exercise number 2, we will solve this system of equations by graphing. Actually, by graphing is not efficient method. We will learn a different method later on, but okay, since we need to solve this by graphing, okay, the graphing has to be accurate. So let's try to sketch the graph as accurate as possible. Okay, here's the first equation and the second equation. Okay, let's graph the first equation. Okay, in order to graph the first equation, from the first equation, let's find the x-intercept. X-intercept, set the y value to 0. Set the y value to 0. Okay, then find x. Okay, y equals 0, then negative 2/3 x plus 7 over 3. Okay, let's multiply this by 3. Then 0 is equal to negative 2x plus 7. So move negative 2x to the left. 2x equals 7. Then x equals 7 over 2. So 7 over 2 comma 0 is the x-intercept, and y-intercept is set the x value to 0. Since x equals 0, y is 7 over 3. So let's plot this x-intercept and y-intercept. X-axis, y-axis. Okay, x equals 7 over 2 is 3.5. 1, 2, 3, 4. 1, 2, 3, 4. So 3.5 x-intercept. Y-intercept is x equals 0, then y 7 over 3. 7 over 3 is 2 point something. So 1, 2, 3. 1, 2, 3. So 2.2 and 1/3. 2 and 1/3 probably over here. So we can graph it. Let's connect these 2 points. Okay, so here it is one straight line. This is the graph of the first equation. Okay, let's graph the second equation. All right, so x-intercept, same thing. X-intercept, set the y value to 0. Then 0 is equal to 2 over 5x plus 1 over 5. Multiply each side by 5. Then 0 equals 2x plus 1. Okay, move 1 to the other side. Okay, 2x to the other side. Negative 2x is equal to 1. Then x equals negative 1/2. So negative 1/2 is the x coordinate. Okay, y-intercept is x equals 0, then y is 1/5. Okay, let's plot this point. Okay, the x-intercept is negative 0.5, negative 1, negative 2, negative 0.5, and y-intercept is x equals 0, then y is 1/5. 1/5, it is somewhere over there. So, okay, this is actually not a good example. Or we can try it this way. Number 2 is you can move. We can use a slope. So we can move 5 units to the right and 2 units up. 5 units to the right. So 1, 2, 3, 4, 5, and then 2 units to the 2 units up. 2 units up is something like this. Then connect these 2 points. Okay, so the y-intercept is probably similar to 1/5, not exactly, but similar. And the intersection of these 2 points is this one. So this is the solution. And let's find the coordinate of this solution. Okay, the x-coordinate looks like 2, and the y-coordinate looks like 1. So the solution is x equals 2, y is 1. Okay, then if we plug in this one, then this should satisfy the first equation and the second equation. So, in order to find the solution by graphing, it is not convenient. We have to draw the line accurately, and we never know if this is 2 or 1, but it looks like 2 and 1. So, we will assume that 2 and 1. And we must check this solution satisfies both equations. Okay, now let's solve this system of equations by substitution. Okay, substitution method is one of the good methods. There is another method, elimination method or addition method. So substitution method is also a good method. Okay, in this case, there are 2 equations, and we have to rewrite one of the equations in terms of x or in terms of y. So from equation 1, we can rewrite this equation so that it will be y equals something. Y equals something. So we will remove negative x to the right side. So let me rewrite the equation. So rewrite this equation so that y equals something, then move negative x to the right side, then y is equal to 3 plus x. So the expression for y is 3 plus x. And substitution means I will substitute this expression for y in the other equation, which is the second equation. So from the first equation, in this case, I solved for y. So we have an expression for y, 3 plus x, and replace this 3 plus x in the other equation. So this y will be replaced with 3 plus x. Then from equation 2, let me change the color. Okay, from equation 2, 3x minus plus y, and this y, the value of this y is 3 plus x. So 3 plus x equals negative 1. And finally, this equation has only one variable x, so we can solve for x. So combine the like term for x plus 3 equals negative 1, minus 3 each side, then negative 4, divide each side by 4, so x equals 1. So we found the value of x, and then we can find the value of y from equation 1 or 2, it doesn't matter. We can use either equation. In this case, we rewrote the equation 1 so that it is y equals 3 plus x. So why don't we use this equation? Then y equals 3 plus 1, so y equals 4. So we got both x value and the y value. So the solution is, okay, let's write the solution in order pair. X equals 1, y is 4. So this is the solution of the system of equations. So substitution is really simple. Rewrite one of the equations in terms of x or in terms of y. Then replace that expression. Substitute the expression into the other equation. Okay, this is number 16 on page 170. Okay, I want to solve this equation by the substitution method. So let's rewrite the first equation. Rewrite the first equation in terms of y. In terms of y, then x equals, move negative y to the other side. Negative y to the other side, then y equals, x equals y. Okay, we got this expression. And then replace this y. Okay, substitute this y for x in the second equation. Okay, so this is the equation 1, this is the equation 2. Then the equation 2 will be 5 times y, x is replaced with y. Then combine the like terms. So 7y equals 6. Then y equals 6 over 7. We got the y value here. Okay, then let's find the x value. Okay, the x value from the first equation, we already know what the x is. So x equals to y. So same y value. That's the x value. So the solution is x is 6 over 7. Y value is the same. So this is the solution. Okay, I'm sorry, I made another mistake. Okay, let me erase. This is, okay, when you combine these two, this is 3y, not 7y. So let me erase this one and correct this. Okay, I'm sorry this happened. So when we combine these two, this is 3y. So 3y equals 6, then y equals 2. So we got the y value. And then from the first equation, we know that x equals y, so x equals 2. So the solution is x equals 2, y equals 2. Okay. Sorry for the inconvenience, I made a mistake. Okay, this time let's solve this system of equations by substitution again. Okay, for substitution, okay, which one should we change? Equation 1 or equation 2? Okay, equation 1 is better, so we can just write the equation 1 as x equals something. Then x equals 5y minus 6. And then substitute this expression for x in the second equation. So from the second equation, x times x is 5y minus 6. So we need to put parentheses because we need to protect the expression 5y minus 6. Minus 3y is equal to 10. And then since this equation has only one variable y, let's solve for y. Okay, distribute, remove the parentheses. 4 times 5, 4 times negative 6, minus 3y equals 10. Combine the like terms, 17y minus 24 equals 10. 17y equals, okay, plus 24 each side, then 34, then y equals 2. So we got the y value. Then let's find the x value. Okay, to find x value, use the first equation. X equals 5y minus 6. So 5 times 2 minus 6. Then 10 minus 6 equals 4. So x equals 4. Then the solution is x is 4, y is 2. So this order pair is the solution to this system of equations. Okay, when we solve a system of equations, do you remember that there are 3 types of equations? So if 2 lines intersect one point, that is an exact solution. But if 2 lines are parallel, then 2 lines never intersect each other. In this case, there is no solution. And the third one is 2 lines are identical. So there are infinitely many solutions. So in this case, this example is the case that the system has no solution. So let's check what happens to this one. Okay, let's use the substitution method. So this time it is better to change the second equation. From the second equation, okay, we can write as x equals something. So x equals, move negative y to the other side, then plus y, positive y, plus 1. And then substitute, okay, from the second equation we got x equals something. Then substitute this y plus 1 for x in the first equation. So from the first equation, 2 times x, and x is y plus 1. Put the parentheses to protect y plus 1. Minus 2y is equal to 0. Then 2y plus 2 minus 2y is equal to 0. Combine the like term. This is 0. 2 equals 0. We have an equation 2 equals 0, and this is false. This is not true. So whenever we have a false equation, then we can conclude that two lines are parallel. Okay, this means two lines are parallel. So there is no solution. Okay, two lines are parallel. Okay, two lines are parallel. How do we know if two lines are parallel? Okay, for example, let's rewrite each equation in slope-intercept form. Slope-intercept form. So first equation, 2x minus 2y is equal to 0. Then negative 2y is equal to negative 2x. So y equals x. We have this equation, y equals x. In this case, the slope is 1. In this case, the slope is 1. How about the second equation? X minus y equals 1. Then negative y equals negative x plus 1. Then y equals, multiply each side by negative, so x minus 1. So this is the second equation. As you see here, the slope is 1. Same slope, so it is parallel. And the y-intercept, this y-intercept is negative 1. In this case, the y-intercept is 0. So two lines are parallel, but they are in different locations. So there is no solution. So when you solve an equation, it's important. When you solve an equation and the result is false, some number like 3 equals 4 or 5 equals 2, this is false, then the result is there is no solution. The system has no solution. Okay, keep in mind this one. Okay, this example is the case that the system of two linear equations has infinitely many solutions. Okay, let's use a substitution. So it is better to change the first equation. The first equation is x equals, move negative 3y to the other side. So 3y plus 12. Then substitute 3y plus 12 for x in the second equation. Then from the second equation, negative 2 times 3y plus 12 plus 6y equals negative 24. Then distribute. So negative 6y minus, okay, this is 12. So minus 24 plus 6y is equal to negative 24. Combine the like terms, then this cancel out. Negative 24 is equal to negative 24. Okay, look at this equation. We finally have an equation which is, this is true. So, okay, if the result is true, then two lines are identical, exactly the same. So since two lines are exactly the same, there are infinitely many solutions. infinitely many solutions. Okay, so this means line 1 and line 2 are identical. So this is the case that the first line and the second line are the same. The two lines are the same. Okay, let's check if it's really the same. So why don't we change equation in slope-intercept form? Slope-intercept form, just to make sure if two lines are the same. Okay, the first equation is x minus 3y equals 12, negative 3y equals negative x plus 12. Divide each side by negative 3. Okay, so 1/3 x negative 4, right? Okay, negative, divide each side by negative 3. Negative 3, negative 3. Then y equals 1/3 x minus 4. So this is the first equation. Okay, let's change the second equation in slope-intercept form. Okay, so 6y equals positive 2x minus 24. Divide each side by 6. Then y equals reduce. So 1/3 x minus 4. So as you can see here, two equations are the same. So since two equations are the same, it has the same graph. So the intersection of these two graphs there are infinitely many solutions. So here is the case. If the result is equal, the result is true, then the conclusion is the system of two linear equations has infinitely many solutions. Okay, so let me write a comment on this. Rewrite this one. Okay, here we can say another important thing here. Okay, when you solve system of equation, okay, the first graph has exactly x equals some value and y equals some value. And when you solve the second equation, the result is always same, like 3 equals 3, 4 equals 4, 0 equals 0. Then there are infinitely many solutions. Okay, the third type is the result will be false equation, 3 equals 4 or 2 equals 0 or 1 equals 5, something like this. Then two lines are parallel and there is no solution. Okay, this is a word problem. Okay, in this case, a contractor bought 30 bundles of shingles and 4 rolls of roofing paper, and it costs $732. And he bought the second time 8 bundles of shingles and 1 roll of roofing papers, and it costs $194. Okay, the question is, okay, then what is the price per bundle of shingles and what is the price per roll of paper? So let's say the price per bundle of shingles is X and price per roll of paper is Y. Okay, then we have to set up an equation for this. So he bought 2 times. So the first purchase is, we can write our first equation for the first purchase. So 30 bundles of shingles, the total amount is, okay, each bundle is X dollars. So there are 30 bundles, so 30 times X, plus the cost for a roll of roofing paper is, okay, there are 4 rolls and each roll costs Y dollars, so for Y. And the total cost is $732. Okay, from the second purchase, we have the equation like this. There are 8 bundles, so 8x is the cost for bundle of shingles, plus 1 roll, so 1 times y is the price of is the cost of roll of roofing papers. Then the second purchase was $194. So we set up a system of equations using the two purchase information. So this is the first purchase, this is the second purchase. So let's use the substitution method. Okay, which is better to change the equation? Second equation is better because we can write as y equals something. Then y equals negative 8x plus 194. And then plug in this expression for y in the other equation. 1. Okay, then from the first equation, 30x plus 4 times y is negative 8x plus 194 equals 732. And then solve for x. So 30x plus minus 32x plus 194 times 4 is 776 is equal to 732. Combine the like terms. So negative 2x plus 776 equals 732. And minus 776 each side. Then negative 2x equals negative 44. Divide each side by negative 2. Then x equals 22. So 22 is the price of each bundle. Okay, then let's find y from the second equation. Okay, we can find y from the second equation. So y equals negative 8 times 22 plus 194. Then y equals negative 176 plus 194. So y equals $18. So y equals $18. So the price per roll of paper is roll of paper, right? So the price of roll of paper is $18.